Questions off I? Is it all good? Yeah. 13? Sure. All right, number 13, it was negative 4 log 2, is that right? So they told us up above, so the negative 4 is going to come down. But they said that log of 2 is about 0.30. So then you'd multiply that. Just get that. Yeah. 17. 0.03. They didn't give us 0.03. So things that I would modify this to would be saying that's 3 over 100, which could expand to log 3 plus log 100. They told us log 3 up above is 0.48. Log of 100 is the same thing as saying log 10 squared, so those cancel. So I get 2, so 2.48. Anything else? Good in the hood? Yeah. Maybe. Yes, it would. Thank you, because that's a subtraction there. Should have been a subtraction there, which would be negative 1.52. Good eye. Like it. Thanks for making sure my errors are correct. Anything else? Good to go? Let's get that last page of the notes out. And let's see. Emily, were you done with this? Or no, you still need to come back, yes?
Yeah, on Fridays or
Sure. Sure. Alex R., you still need to finish this? Sometime this week? Or next week? Or the week after? I'm just kidding. Anybody else? There's so many Algebra 1 kids. Oh my gosh. Henry, I think you had one to make up as well, right? I don't even know who else is in here. Spencer. That's it. Cool. All right, we're good to go. You got the notes out? All right. So we're going to start inverses of logs and exponential functions and also their graphs. Remember, an inverse function is reflected over the line y equals x, which is a 45-degree line that goes through the origin. Okay, so we just need to know that these undo each other. It's not the best slide. Not going to help us. All right, simplify the expression. When you have log just by itself, those will cancel, so I just get an answer of 2 here. This will become log base 3 of 3 to the 2x, because I could change 9 to 2 squared. These now cancel, so my answer just comes out to 2x. These cancel, leave me just x. And then we need to change 8 to base 2, so that's 2 to the 3rd power to the x. Those cancel each other out, so we just left with 3x. Questions for me there? You good? I'm sorry, I'm standing in the way. Yeah. 1. So 10 raised to the log of x. So we know that this, if a log is by itself, that's base 10. So they just cancel each other. Was that your question? Okay. All right. So we found inverses before. So the first part of starting an inverse is you go x equals 3 plus y. So you interchange x and y. Then we solve for y. So I subtract 4, divide by 3. So this is the inverse of that, right? So being that we flip-flop x, y, means we're going to still flip-flop x, y when we have other things. Ready? Remember that, right? I hope. Or you'd seen it before in me. All right, so find the inverses of each. So this is going to become x to the 4 raised to the y. There's two different answers that work, both log and natural log. So log and ln undo exponents. So it's your choice which one you want to do. So they're probably trying to guide us to say do the log of both sides. So I get log x equals y log 4, because the y would come down. Then I can divide both sides by log 4, so I get y equals log x over log 4. So that's the inverse to what was given. Number 6, we have to realize f at x is a fancy way of writing y. So we can flip-flop that. So I'm going to change it to x equals 3e to the y. Is that okay so far? Now I did that as I realized this is y. Divide each side by 3. What undoes e? Natural log. Very good. So I'm going to do natural log of that. Natural log of that. So it's going to give me y equals ln x over 3. Now, a question that comes often with this is, do you have to have x over 3 in parentheses? Not always. Okay? The reason I put it in parentheses is I'm doing the natural log of that whole thing. But if I can decipher that your ln and your x over 3, and x over 3 is definitely exclusive, that's fine. Unfortunately, some people will write ln x all over 3, and that's incorrect. Does that make sense? So it's your choice. If you want to have it grouped, fine. If you have it ungrouped, make sure I realize that x over 3 is by itself, and you're not doing it all over 3. Let's see. I get y equals 1/3 6 to the x minus 3. X equals 1/3 6 to the y minus 3. So I'm just interchanging x and y. Solve for y. Multiply both sides by 3. So we have to figure out how to bring the exponent down. We can either do natural log or log. It doesn't matter. So if I do the log of both sides, I get log 3x equals y minus 3 times log 6, because the exponent can come down front. I'm going to divide each side by log 6. Oops, nope, stop, stop. And then we're going to add 3 to both sides. So that's the inverse. So again, I showed you probably more steps than you would have to do. Of course, you can show it in less steps, and I'm fine with that. Can I move this back up so I can see what my problem is? Where'd you park, Kaylee? Oh, okay. Michelle, sorry I said that the other Kaylee is taking this class as remote. And then when you said Kaylee's coming, I didn't put 2 and 2 together. Yeah. Let's see here. Cora's missing. Anna's missing. Okay. All right, moving on up. All right. Y equals 10 to the x plus 4 plus 2. Flip-flop x and y. Y plus 4 plus 2. Subtract 2. Oops. Okay. I would go ahead and do log of both sides. If I do log of both sides, log and 10 would cancel each other out. Yes, you want to have that grouped because you're doing the log of x minus 2. So I'm going to get log x minus 2 equals y plus 4. So y equals log grouped x minus 2 minus 4. That's my inverse. Is that better? Idiot. We all right? How am I doing on notes? Like 7,000 more problems to do? So I'll go real fast. It's like, no. Okay. All right, find the inverse of each function. And then state the domain and range of both the original and its inverse. Okay, so my domain of this is round bracket 0 to infinity. Being that log, I can get a negative number for the log. Let's see, can I do that? Yeah, so I can get, my range is going to be this. Because if I put little decimals in for log base 3 of x, if I plug like 0.2 in, that would give me a negative answer out. So the domain's restricted because the log can't be 0 or a negative. So it's a rounded bracket. So I can plug a little decimal in. That's fine. That's of my original. Let's find the inverse. Oops. Boy, I tell you, can't take me anywhere today. So to undo this, I'm going to go 3 raised to 3 raised to the. So that's 3 to the x is equal to, those cancel, y. And now we have to be careful. Was the domain originally restricted? Okay. Was my range originally restricted? So this appears that the domain could go negative to positive infinity, and the range could go 0 to infinity. And actually, if you leave it like that, you're fine. Just flip-flop the domain and range. I don't think we want to worry about onto for these. Number 10, f at x is the same thing as y. Yeah. No, it's log base 3. So what undoes log base 3? So basically, you'd have to go, if you wanted to do that way, you could convert it to this. And we're going to go backwards on the seashell. 3 to the x is equal to y. So we could undo it that way if you wanted to. Okay. Number 10, I'm going to make this x equals ln y. E undoes natural log. So I get e to the x. Oh, let's do the domain of the original. 0 to infinity. Range can indeed be negative numbers. So that means the domain of the inverse is going to be that. The range is going to be 0 to infinity. So you just flip-flop them. You have to be careful on the domain of number 11 because I have it as x minus 1. So what would make that 0? So it can go from 1 to infinity. If you plug 1 in, you get 0. So I have to plug like 1.00 whatever. And that's going to work for us. Our range can indeed be negative to positive infinity. Flip-flop x and y. Y minus 1. Because that's that, make 2 to raised to the 2 raised to the. And so I'm going to get y minus 1 equals 2 to the x, which is y equals 2 to the x plus 1 down low. Domain, negative to positive infinity. Range, 1 to infinity. So again, just flip-flop the domain and range directly for the inverse because we interchange x and y. Domain of this one, 0 to infinity. Range, negative to positive infinity. X equals 2 ln y. Divide by 2. Do the exponential of both sides. Make that in parentheses. So I'm going to get e raised to the x over 2 is equal to y. So that's my inverse. And my domain will go negative to positive infinity. And my range will go from 0 to infinity. That should work. How many more questions I got? I don't even know. 1. So I got, hang on. So that, I'm on 13. There. Keep going. There, okay. What time are we out of here? Okay. Questions so far? Do you need me to go through all of the domains or all of the inverses? Anyone need it? Any of those you want seen? All of them? None of them? Some of them? Yeah. Yeah. All right, so I'm going to go x equals 1/5 log 5 of y minus 4. Is that okay so far? Add 4 to both sides. Multiply both sides by 5. Oh, wait. Yeah, by 5. And that's going to cancel that. So I get 5x plus 20. We'll just distribute that over. Equals log base 5 of y. 5 raised to the 5 raised to the. So I get 5 to the 5x plus 20 as an exponent is equal to y. That's the inverse. Yeah, we're good. Any of those others you wanted to see? We're good. I didn't find the domain and range. Apologize. All right, so there the characteristics of the graph of an exponential function. Inverses will be symmetric over that green line that's graphed. Okay, meaning I could fold it over that 45-degree line. It would lie right on top of itself. That's the main thing that you're looking for when you're taking a look at inverses, okay? All right, so I can't have any negative values in here. So let's think about some 2 points that we could probably do. If I plug 1 in, what is log base 3 of 1? What's the log of 1? 0. So I get 1 comma 0 here. I could plug 3 in as well, because 3 is the same thing as 3 to the first. Log base 3 of 3 is going to be 1, so I get 3 comma 1. Oh, wait. Oh, my gosh. I can go back to bed. 1 comma 0 is here. 3 comma 1 is here. So it starts here and just starts growing. Notice, it starts here. Okay? The arrow's not continuing to point down. The reason why that doesn't work is some values that we have to worry about. Okay, now, question for you. What would happen if I plugged in log base 3 of 1/3? What do you think? Is this the same thing as log base 3 of 3 to the negative 1? So 1/3 comma negative 1 is like here. So it's going to keep going. And the vertical asymptote is the x-axis. This is going to do the same thing as those points, although everything's going to go down 2. So this comes down 2. This comes down 2. This comes down 2. So if you understand the shifting, you don't have to worry. If you have the kind of the parent function to it, you don't necessarily have to worry about plugging in values with log base 3 of x and then subtract 2. And if you realize the whole thing shifts down. Questions? Good. All right, log base 3 of x. So the same thing, we've done this. We had that. We had this. We had this for my original. What does this do? It's grouped. So what does it do when it's grouped versus non-grouped? Right 2. So my vertical asymptote is now going to change to here. Okay, so I'm going to go right 2, right 2, right 2. That's when that one does. So when it's grouped, remember it shifts opposite of what you would think. Right, left. This is probably where you're starting to see where the domain is getting affected. On the original, the domain goes from 0 to infinity, round bracket on the 0. Range keeps going from negative to positive infinity. All right. We got that. Okay. Write the exponential equation based on what we know. Okay. Write the log equation. Log base a of b plus h comma k. All right, so my h value is my asymptote. What's my asymptote there? 0. So that's going to be 0. Being that my first point is resting right on the x-axis, I can also say this is going to be 0. So I'm going to change that to this. And then let's start finding some a and b values. I'm going to change, I made an error. I want this to be an x. I'm going to change that to an x. So I'm going to take that 1 comma 0. I don't know why they have it negative 0, but log of 1 is 0. I messed up. I got to come back to these. So I'll just give you an assignment. I have to think on those a little bit more. A, B, C, D, E, F, G, H, I, J, J. So, yeah, we don't even have those. You guys want a lot of homework? Oh, come on. Is it your parents are the ones that are emailing Mr. Silva saying Mr. Sharp's giving too much homework? I'm just kidding. What do we say we do? 9J every other odd. So do 1, skip 3, do 5, skip 7. If that's too hard for you, just do all the odds. If that's still too hard for you, do them all. I guarantee you'll get them done. But let's see. So do 1, skip 3, do 5, skip 7, do 9, skip 11, do 13, skip 15, do 17, skip 19, do 21, skip 25, skip 27, 29. Sweet, like 8 problems. Good enough for Friday? I'm happy about it.